Hey guys, in this video we're going to talk about solving multi-step equations. So last time we looked at solving one-step and two-step equations. So what I like to do is just draw a line through the equal sign showing that the left and the right side are different entities. And the goal is to get the variable by itself. So we're working on the left side for this one, and we want to get rid of what's happening to x. Okay? What's happening to x is addition by 3. So we want to do the opposite of that, which is subtraction by 3. So we have to subtract 3 from both sides to keep the scale balanced. On the left side, I just get x, right? Because plus 3 and minus 3 go to 0. And then on the right, 10 minus 3 is 7, and we get our solution of x equals 7. Now we can always check to see that we did an equation right by taking our answer and subbing into the original equation for x. So the original equation was x plus 3 equals 7. I claim that x equals 7 is my answer. What we do is we plug in 7 for x, so we just substitute it in, and we have 7 plus 3, does that equal 10? And indeed it does. 7 plus 3 is 10, so 10 equals 10. You get a true equation, so therefore you did the equation correctly. Now let's look at the two-step equations. So again, we're going to work on the side with the variable first. We want to isolate the variable. That's the end goal here. And we want to start with the operation, quote-unquote, furthest away from the variable, which is addition by 8. You see how addition by 8 is further away than multiplication by negative 3, right? Both things are happening to x. We have addition by 8 is happening, but negative 3 times x is also happening. But the operation that's further removed from x is the positive 8, so we want to undo that first, okay? So how do we undo addition by 8? We subtract 8 from both sides. That clears to 0, and on the left, I just carry what's left down, which is negative 3 times x. On the right, I have 20 minus 8 is 12. Okay? Now, one thing that students will get confused is multiplication and subtraction here in this case. If you want to add 3 to both sides, no, you shouldn't do that, because the x is not, we're not subtracting 3 from x, we're multiplying negative 3 by x. So we don't want to do the opposite of subtraction by 3, because that's not what we're doing. We're multiplying by negative 3. So we want to do the opposite of multiplication by negative 3, which is dividing by negative 3 on both sides. So that clears to 1, which we expect it would. And so we get x equals 12 divided by negative 3 gives us a negative 4, and that's our answer. We can always check. Again, any equation you solve, you can check by taking your original equation and plugging your answer into the variable. So is it true that negative 3 times negative 4 plus 8 equals 20? Is that true? Well, negative 3 times negative 4 is a positive 12. 12 plus 8 is indeed a positive 20. So it checks out. We did this correct. Okay, so we want to solve the equation and check our solution. Okay, so I'm going to start by drawing a line through the equal sign with this first one. And what I want to do, I see 3 operations on the left side happening to x. I see multiplication by 2. I see subtraction by 5. And I see division by 3. So I want to get rid of division by 3 first, since it's the furthest away from x. So how do I get rid of division by 3 is multiplication by 3. So I want to do that to both sides. Now, I am multiplying by 3, which is 3 over 1. I'm not multiplying by 3 over 3, which means you shouldn't do any kind of distributing. Right? That's a common mistake that students make. They'll distribute that 3 up there, but that's not what we're supposed to do, because these 3's already divide each other out. We don't distribute. So on the left, when those two 3's cross cancel, we get 2x minus 5. On the right, 5 times 3 is 15. And now I just solve this like a normal two-step equation. On the left, I want to get rid of subtraction by 5, so I want to add 5 to both sides. On the left, I get 2 times x. On the right, I get 15 and 5 make 20. Finally, to get rid of multiplication by 2, I need to divide both sides by 2. So 2 divided by 2 clears to 1, and I get x is equal to 20 divided by 2 is 10. So my solution should be x equals 10. I can check myself with the original equation 2x minus 5 over 3 equals 5. And to check myself, I just plug in 10 for x and see if it's true. So I have 2 times 10 minus 5 over 3. Is it true that that equals 5? Well, on top, 2 times 10, 20 minus 5 is 15, so I get 15 divided by 3 equals 5. Is that true? Yeah, that's true. 15 divided by 3 is 5. So that's true, so we did it correctly. Let's do another one. So we have negative 5t minus 8 equals 12. I'm going to start by drawing a line through my equal sign. And my variable this time is t. So I'm going to be working on the left side. And I want to get rid of subtraction by 8 and multiplication by negative 5. So subtraction by 8, multiplication by negative 5. So what's happening furthest away from t is subtraction by 8. So I'm going to get rid of that first. How do I undo subtraction by 8? I want to add 8 to both sides. Now negative 8 plus 8 clears to 0, so that goes away. And I'm left with negative 5 times t is equal to 12 plus 8, which is 20. Now a common error that I see a lot is students will add 5 to both sides at this point. But that's not right, because it's not t minus 5. It's negative 5 times t. What's happening is multiplication, not subtraction. So I want to do the opposite of multiplication by negative 5, which is division by negative 5. When I divide negative 5 by negative 5, it clears to 1, so I'm just left with t equals 20 divided by negative 5 is negative 4. And for an exercise, you should check your answer. So check with the original equation negative 5t minus 8 equals 12. Plug in negative 4 here and see if you get a true equation, and you should. Okay, let's do the next one on this page. We have 79 equals 5u plus 9. This time I'm working on the right side because my variable u is on the right side. So what do I need to get rid of first? Well, the furthest operation from u is plus 9. So I want to get rid of that first by subtracting 9 from both sides. So when I do that, that clears over here, and I'm left with 5u on the right side. And on the left side, 79 minus 9 is 70. So the last thing to do is to consider the opposite operation of multiplication by 5. What's the opposite of multiplication by 5? Division by 5. So we want to divide both sides by 5 to get that variable u alone, and that clears. So I'm left with u is equal to 70 divided by 5 is 14. Again, you can check this by saying, is it true that 79 equals 5 times 14 plus 9? Is that true? And it should check out. Okay, so here's a little cheat sheet of how to solve multi-step equations. So the first thing you usually want to do is get rid of parentheses, because parentheses make things look clunky. So get rid of parentheses by using the distributive property. Okay. If you can, combine like terms on each side of the equal sign before you start moving things around. Number 3, move variable terms to one side. And finally, isolate the variable. So these are the 4 steps that you can go through to solve a multi-step equation. So, let's practice this, all right? So does step 1 apply? Do I have parentheses to get rid of? Yes, I do. I can get rid of parentheses on the left side by using the distributive property here. So 4 times x is 4x. 4 times -1 is -4. Okay, so I did step 1. Now, does step 2 apply? Combine like terms on each side of the equal sign. Well, on the left side, do I have like terms? No. On the right side, do I have like terms? No, I just have 8. So step 2 doesn't really apply. Step 3, move variable terms to one side. So I'm going to leave the x's on the left side, and I'm going to move everything else over to the right side. Okay, so I'm going to go ahead and undo subtraction by 4 by adding 4 to both sides. And I'm left with 4x is equal to 8 and 4 make 12. Okay, so I moved my variable to one side, which is the left side, and everything else went to the right side. So I technically moved the constants over, but the point is you want your variable on one side, your constants on the other side. Okay. Finally, I'll isolate x by undoing multiplication by 4 by dividing both sides by 4. So I get x is equal to 3. And that's my answer. You can check yourself, right? And I'm not going to check for every single time, but when you're doing your homework, you should, because it's going to tell you right away if you got the right answer, if you did something incorrect. So I'm going to check by subbing 3 in for x into my original equation. Is it true that 4 times 3 minus 1 equals 8? Is that true? Well, doing PEMDAS, parentheses first, 3 minus 1 is 2, so I get 4 times 2 question mark equals 8. On the left, 4 times 2 is indeed 8. So, did this correctly. Okay. So our answer for that was x equals 3. Let's do the next one. So first step, get rid of parentheses. There's no parentheses to get rid of. So we move on to the second step. Combine like terms on each side of the equal sign. Well, on this side, do we have like terms to combine? Nope. Do we have like terms to combine over here? Nope. Again, this was step 2 that we're looking at. We're trying to see if there's stuff to combine on the same sides, and there's not. So we move on to step 3, which is get the variables on one side, get the constants on the other side. So I'm going to choose to move all my variables to the left side, and I'm going to choose to move all my constants to the right side. That's what I'm going to do. And you could do it the reverse way. It doesn't matter. Like, you could move your variables to the right side if you wanted, but you're going to get the same answer. Okay, so to do that, I look at the right and I say, okay, I want to move the 3x to the left. How do I do that? Well, I have to get rid of it on the right side by doing the opposite of addition by 3x, which is subtracting by 3x. Okay, when I do 3x minus 3x, that goes away. Now I have 9x minus 3x is going to give me 6x when I combine like terms. And then on the right, I'm just left with 6. So I just moved my variable from the right side to the left side by subtracting it from both sides. Okay, I couldn't add it. If I added it, I would have gotten 6x on the right side, and that wouldn't have canceled it out. I had to cancel it out by subtracting 3x. Okay, so at this point, I can move my constant -1 over, and I want to get rid of it by doing the opposite of subtraction by 1, which is adding 1 to both sides. So I get 6x is equal to 6 plus 1 makes 7. And finally, I'll divide both sides by 6 to give me x equals 7 over 6, which is fully simplified. And you can check this if you want, but that's our final answer. All right, let's try another one. I encourage you to pause the video, try this next one on your own. Step 1, do we have parentheses to get rid of? Oh, we sure do. On the left side, right, I can use the distributive property here. So 2 times x gives me 2x. 2 times positive 3 gives me a positive 6. Step 1 is complete. Now step 1 says combine like terms on the same side. Do I have like terms on this side? No, I do not. So I move on to the right side. Do I have like terms here? Yes, I do. 8x minus 1x, 8 bananas minus 1 bananas is 7 bananas. So step 2 says I can combine this to 7x. So step 1, I move the parentheses. Step 2, I change the right side by combining like terms. Now step 3 says move the x's to one side and the constant to the other. So I'm going to move the x's. I want to move my x's to the right side, so I'm going to get rid of this, right? How do I make it disappear on the left? The only way to make it disappear is by subtracting 2x from both sides. So I need to subtract 2x from both sides to make that disappear. And I'm left with 6 is equal to 7x minus 2x is going to give me 5x. Let me write this up here because I'm running out of room. 6 equals 5x. On the right, what's happening to x is multiplication by 5. How do I undo multiplication by 5? I need to divide both sides by 5. And when I do that, I get x is equal to a fraction 6 over 5. And that is my answer there. Again, you should check it. I'm not going to do that here just for time's sake, but you should check to see that that's right. Alright, last one on this page. Again, I encourage you to pause the video, try this one on your own. Does step 1 apply? Do I have parentheses to get rid of? No, I do not. Does step 2 apply? Can I combine like terms on the same side? Yes. On this side, no. But on this side, yes. 3z plus 9z is equal to 12z. So 12 times z is equal to 121. Now, my variables on one side and my constants on the other, so I don't have to do any more, I don't have to move variables to one side. The variable term is already on the left side. So to finish this off, I need to undo multiplication by 12 by dividing both sides by 12. And I get that z is equal to 121 over 12. And this cannot be simplified, I don't think. No. So that is our answer there. Weird fraction, but it works. Alright, let's try some of these. Step 1, do I have parentheses to get rid of? Yes, I do. Right here. Use the distributive property. 2 times x is 2x. 2 times negative 1 is negative 2. Pull everything else down. Step 1 is complete. Step 2, do I have like terms on the same sides? On this side, I have nothing. I just have 8. No combining. On this side, I have like terms. I have 2x and a positive 4x makes a positive 6x. Right? And notice, I'm not introducing anything new to the left side. That's why I'm not adding anything over here, because the stuff on the left side was already there. I'm just condensing it, right? I'm just condensing it. I'm not introducing anything new, so I'm not doing the same thing to both sides, if that makes sense. So 2x and 4x together make a 6x, and I still have that negative 2 hanging out there. All right, now on the left side, I want to get x alone. That's the whole goal. How do I do that? Well, I need to first get rid of subtraction by 2 by adding 2 to both sides. So that goes away, and I'm left with 6 times x on the left, and on the right I'm left with 8 plus 2 is 10. Finally, I'll divide both sides by 6 to get x alone, and I can simplify by 2. So 10 divided by 6 simplified by 2, 10 divided by 2 is 5, 6 divided by 2 is 3. So x is equal to 5 over 3, and that is my answer. Alright, let's try the next one. So I'm working on the right side. Does step 1 apply? Do I have parentheses to get rid of? No, I do not. Does step 2 apply? Can I combine like terms? Maybe. How about I rewrite it like this? How about I rewrite it to make it look a little bit better? Now this fraction I can split up, right? Because I'm under the same denominator 3, I can split this up to x over 3 minus 1 over 3. Do you see why this is the same as this, right? Because I have the same denominator here, combine the numerator and we get the same thing that's circled in purple. Okay, so there's that. So do I have like terms when I write it like this? Well, yeah, I do. I have negative 2 and a negative 1 over 3. So negative 2 minus 1 over 3. You can do this with your calculator. You can do it by hand. I don't care. But at the end of the day, what you're going to get, instead of negative 2, we're going to write that as negative 6 over 3. Same denominators, right? Negative 6 over 3 minus 1 over 3 is negative 7 over 3. Okay, so let's do that. So this was step 2. We're combining the two constants. Those are like terms, okay? Negative 2 minus 1 over 3 is negative 7 over 3, and we still have that plus x over 3. Okay? All right. Now, to get the x by itself, I can undo subtraction of 7 over 3 by adding 7 over 3 to both sides. So I'm getting x alone at this point. So there's nothing else to combine. And I'm actually going to write this over here. So what's 8 plus 7 over 3? I'm going to do this in the calculator. Feel free to do that if you want. This is 31 over 3. So I get 31 over 3 is equal to x over 3. Okay. Now what's happening on the right side to x is division by 3. So I want to do the opposite of division by 3, which is multiplication by 3. So those clear, and I'm left with x equals. Now, 3 times 31 over 3. Again, this is understood to be over 1, so these guys cancel, and I'm just left with 31. 31 is my answer. You should check in the original equation to see if, when I put in 31 for x, if I get a true statement. Okay? Alright, let's do the next one. So, step 1, do I have parentheses to get rid of? I certainly do. I have this guy to get rid of. So, using the distributive property, negative 2 times t is negative 2t. Negative 2 times negative 4 is a positive 8. Okay, so I just got rid of the parentheses. Step 1. Now, step 2 says, hey, if you have like terms on the same side, go ahead and combine them. Make your life a little easier. Do we have like terms on the right side? No, we just have a number 27. Do we have like terms on the left side? Yes, we do. We have a negative 2t and a positive 6t make a positive 4t. Okay? So combining like terms, that gives me a positive 4t. And now I want to isolate the t. So on the left side, I can undo addition of 8 by subtracting 8 from both sides. And I get 4t is equal to 27 minus 8, which is 19. Finally, dividing both sides by 4, I get t is equal to 19 over 4. And that's my answer. Alright, now it's getting fun. Right, but it's the same process, right? The goal is to get the variable by itself. That's the whole thing. I mean, it doesn't matter what order you do things in, but you want to make sure you get that variable by itself. So, I have two sets of parentheses here that I can get rid of. I can get rid of these. I can get rid of this. Okay? So the green, 2 times 6 is 12. 2 times negative 8k is a negative 16k. Alright, perfect. Green is done. Purple, I have a negative 3 times a negative 2. Be careful with your signs. Negative 3 times negative 2 is a positive 6. Okay? Negative 3 times a negative 3 times a positive k is a negative 3k. Perfect. Step 1 is complete. Step 2, hey, if you have like terms on one side, why don't you combine them? Make your life easier. Combine them if you can. Do I have like terms? I sure do. On the left side, I have 12 and 6 are like terms, And I also have negative 16k and negative 3k are like terms. So 12 and 6 added together make 18. Took way too long for me to do that. Negative 16k and negative 3 make, or negative 3k make a negative 19k. Alright, step 2 is complete. What I can do at this point, if you like, you can always write your variable term first because, addition commutes. In other words, instead of writing 18 minus 19k, to make this look a little familiar, I can write negative 19k, positive 18. It's the same thing. It's the same exact thing, okay? Okay, so now what I can do is I can subtract 18 from both sides to get that k alone. And I'm going to have to rewrite this because I'm running out of room. But on the left side, I get negative 19 times k. On the right side, 20 minus 18 is going to give me 2. And finally, I can divide both sides by negative 19. And I get my answer. I get k is equal to 2 over negative 19, which I can move the negative to the top. That's more of a convention that people do. I mean, it wouldn't be wrong if you left the negative in the bottom, but people usually just let it float kind of in the middle. So k is equal to negative 2 over 19. Okay, let's do one more here, and let's see how many more we have to do. Okay, we've got quite a bit. Okay. Alright, let's try this one. Draw my line through the equal sign. Do I have parentheses to get rid of? Yes, I do. I have this guy right here. So 2 times 8x is a positive 16x. 2 times negative 7 is a negative 14. Alright, those are gone. Moving on to step 2. Do I have like terms to combine on each side? On this side, no. I have an x term and a negative 4. That can't combine. But on the right side, I can combine 16x and a negative 3x to give me a positive 13x. So those combine to positive 13x. Okay, so that's where I'm at. Now, step 3 says move your x's to one side, move your other number terms to the other side. So I'm going to start by subtracting 3x from both sides to move the x's to this side, to the right side. And I get negative 4 is equal to 13 minus 3 gives me 10x minus 14. So I just moved this guy by getting rid of it, by subtracting it from both sides. Okay, now on the right, I can isolate the x term by next adding 14 to both sides. Okay, negative 4 and 14 make 10. And finally, I can get rid of the 10 being multiplied on the right side by dividing both sides by 10. So 1x equals 10 divided by 10 is 1, and that is my solution. Okay, let's try this one. So drawing my line through the equal sign, do I have parentheses to get rid of? Yes, I do on the left side. Negative 6 times v is negative 6v. Negative 6 times positive 4 is a negative 24. Step 1 is complete. Step 2 says, hey, if you have like terms on the same side, go ahead and combine them. Well, the same side, this is the same side. Do I have like terms? No, I have a v and a constant. On this side, do I have like terms? No, I have a v and a constant. So step 3 says, hey, go ahead and move your variables to one side. So I'm going to move this over here. And the only logical way to do that, to make it disappear on the side, is to add 6v to both sides to make it disappear. So negative 6v plus v clears to 0. And on the left side, I'm left with negative 24. And on the right side, negative 2v plus 6v is positive 4v plus 12. Okay, so now I can go ahead and work on the right side and get rid of addition of 12 by subtracting 12 from both sides. So that gives me negative 36 equals 4 times v. Finally, let's get rid of the multiplication of 4 by dividing both sides by 4. So negative 36 divided by 4 is going to give us our answer. V is negative 9. And again, I encourage you to check with your original equation. Go ahead and plug in negative 9 in for V into this guy and see if you get a true equation. Okay, let's do this one down here. Do I have parentheses to get rid of? I do. On this side, I have parentheses. I have negative 2 times x gives me negative 2x. Negative 2 times positive 1 gives me negative 2. And on the right side, I have, be careful, there's a negative attached to this 4 that's being multiplied, okay? Be careful with that sign. So negative 4 times 4x and negative 4 times positive 6. Negative 4 times 4x is a negative 16x. And a negative 4 times a positive 6 is a negative 24, okay? Step 1 is complete. Step 2 says if you have like terms on the same side, go ahead and combine them, make your life easier. On the left side, I do not have like terms. On the right side, I do. 4 and negative 16x. So 4x minus 16x is negative 12x. So those combine. So step 2 is complete. Step 3 says to move your x's to one side. I am going to add 2x to both sides to make this negative 2x disappear. So that clears, and I'm left with negative 2 equals negative 12x plus 2x is negative 10x minus 24. Okay. Now I am going to work on the side with my x. I'm trying to get x alone, so I want to make this disappear first, and to do that I have to add 24 to both sides to make that disappear. So on the right side I'm left with negative 10 times x. On the left side I'm left with 22, and at this point I can divide both sides by negative 10, and I get x is equal to 22 divided by negative 10. If I simplify by 2, it's going to be 11 over negative 5, right? So that's our answer. Okay. Let's try this one. So this time we have some fractions. That's okay. So step 1, get rid of the parentheses. So dupe, dupe. And then over here we have dupe, dupe. So on the left I have 1/4 times 8y. I'll do this off to the side. 1/4 times 8y over 1. Well, the 4 goes into itself once, 4 goes into 8 twice. So multiply straight across, you just get 2y over 1, which is 2y. Okay? So this becomes 2y minus 6, right? 1/4 times negative 24. Let me do it over here so you guys can see. 1/4 times negative 24 over 1. Again, cross simplifying. 4 goes into itself once. 4 goes into negative 4, negative 6 times. Multiply straight across to give us negative 6 over 1 is negative 6. Then we have the plus 3y. On the right side, when I do my distributive property, 16 times y is just 16y. 16 times positive 1 is positive 16. Okay? Alright, so that was step 1. I got rid of my parentheses by using the distributive property. Step 2 says if you have like terms on the same side, go ahead and combine them. I don't have like terms on this side because I have a y term and I have just a number. But on this side, I have 2y and positive 3y can be combined to 5y. So this is 5y minus 6 equals 16y plus 16. And maybe I'll just scooch this a little closer. So 5y minus 6 equals 16y plus 16. Okay, next thing I want to do is move my variables to one side. So to do that, I'm going to get rid of the 5y on the left side, move it to the right side by subtracting it. So if I subtract it, it goes away on the left. Whatever I do to one side, I have to do the other. So 16y minus 5y is 11y. Okay, now I can subtract 16 from both sides. So it gives me negative 22 equals 11 times y. Divide both sides by 11 to get y equals negative 2. And that's my solution. Alright, let's do one more like this. So step 1, get rid of the parentheses. So I have parentheses there, parentheses there. So with the green, 2/3 times 12x over 1. Okay? Cross simplify. 3 goes into itself once. 3 goes into 12 4 times. Multiply straight across to give me 2 times 4x is 8x over 1, which is just 8x. Okay, so that becomes 8x. Now 2/3 times negative 3 just becomes negative 2, right? Because 2/3 times negative 3 over 1. Cross simplify. 3 goes into itself once. It goes into itself once. Multiply straight across to give me negative 2 over 1 is negative 2. Okay. Alright, so that's that. Plus x minus 6 equals, now on the right side, I can get rid of the parentheses by distributing. 2 times x is 2x. 2 times positive 1 is positive 2. And now step 3 says, hey, if you have like terms on the same side, go ahead and combine them before moving your x's. On this side, I do not have like terms. On this side, I do. I have these guys are like terms, and I have these guys are like terms. So 8x plus 1x is 9x, and negative 2 minus 6 is negative 8. And maybe I'll write this, well, actually we'll leave it like that. 9x minus 8, let's do it. So 9x minus 8. Alright, so here's where I'm at. Want to move my x's to one side, so again, it doesn't matter which side you move, it just matters that you do the same thing to both sides. So I am going to subtract 2x from both sides to get rid of the x on the right side. When I do that, that clears, and I'm just left with 2 on the right side. 9x minus 2x is going to give me 7x, and then I still have that minus 8. Okay, so from here, I can add 8 to both sides to give me 7x is equal to 10. Divide both sides by 7 to give me x equals 10 divided by 7, which cannot be simplified. Okay, so we can always isolate variables even if there aren't numbers involved. So for example, if we want to solve for p in this equation, we would just act like it was any normal kind of equation, and any variable terms, we can just treat them like they're constants, right? So first thing, we don't have any parentheses, so we don't have to use the distributive property. On this side, we don't have like terms. We have a p term, a q term, a g term, but we don't have any terms that we can combine. And we don't have like terms on the right side either. So we want to isolate the equation for p, so that means I need to move this over and I need to move this over in order to get p by itself. Okay, so I'm going to start by adding 1q to both sides. Just like you would add 2 to both sides if you were subtracting 2. Since you're subtracting q, you would add q to both sides to clear that out to 0. Okay, so let's just rewrite what we did. So we got rid of the q, and we're left with p plus 3g on the left side equals 4 plus q on the right side. We can't combine anything, okay? Now on the left side, I still want to get p by itself, so I need to undo addition by 3g. So the opposite of adding by 3g is subtracting by 3g. So if I subtract 3g from both sides, I am left with p alone, which is what I wanted. I wanted to solve for p. And on the right side, I have 4 plus q minus 3g. And I can't combine any of these three terms, so that is my final answer. P is equal to 4 plus q minus 3g. Let's try another example. Okay, so we want to solve for x, and to get x by itself on the left side, I need to undo division by yz. Now what's the opposite of dividing by yz? Multiplying by yz. So I need to just multiply both sides by yz, and that clears, and I'm left with x by itself, which is what I wanted, on the left, and then p times yz, or if you wanted to write it, you could write it x equals pyz. That all means multiplication, and that is my answer there. Okay, let's do another one. I want to solve for v in this equation. So the v is on the right side, so that's where I'm going to start. And since I'm trying to solve for v, I'm going to write the v term in front. So negative 3v can come to the front, and the positive 6m can just stay in the back. So I just did some rearranging before I actually started the problem. Okay, now since I want to get v by itself, I need to first get rid of this by subtracting 6m from both sides. And maybe I'll make some room since I can't combine these. So I'm going to subtract 6m from both sides. Cannot combine. And I'm left with 2d minus 6m is equal to negative 3 times v. Now I'm trying to find v, so I need to undo multiplication by negative 3 by dividing both sides by negative 3. And that is it. So you get v by itself, which is what we wanted. And then on the other side, we get 2d minus 6m all divided by negative 3. And you could simplify this if you wanted to, but I'm just going to leave it like that. So that is v. All right, let's do one more. Solve for n. So n is right here. So I want to move everything that doesn't involve an n to the other side. So I'm going to first start by subtracting 3m from both sides. And so just rewriting this horizontally, I get d minus 3m is equal to 4 times n. Okay, now I want to get n alone, so on the right side, I need to undo multiplication of 4 by dividing both sides by 4. And I do get n by itself. N is going to equal d minus 3m over 4, and that is our answer. Let's do some word problems. So Eddie needs to pay $690 in rent for his ski shop. He rents skis to customers for $40 a day. How many customers does Eddie need to rent skis so that he can pay his rent and have $150 left over? So I encourage you to pause the video at this point and see if you can come up with an equation for this situation. What is our unknown? Okay, so our unknown, the question that we're asking is how many customers does Eddie need? So I'm going to say, since my unknown is customers, I'm going to say C is going to be my variable, and I'm going to let that be the number of customers. Okay. So he needs to pay $690 in rent, and so I guess the question is, well, what's the profit going to be? He wants the profit to be $150. That's how much he wants to have left over. He's going to rent the skis to customers for $40 a day, so $40 per customer. 40 times C is $40 per customer. And then he also needs to pay $690 in rent. So whatever he makes from the $40 per customer, we need to take away $690 for rent. Okay, so this is our equation. So he wants 150 to be left over when he rents skis to his customers and then takes away the cost of the rent. All right, so let's go ahead and solve this equation for C. How many customers does he need to have 150 bucks left over? And then we're going to check our answer to see if it actually makes sense. All right, so I want to get C by itself, so I'm going to start by adding 690 to both sides. Let's see. So this is going to be 840. So we have 840 equals 40 times C. And so now what I need to do is I need to divide both sides by 40 to get C by itself. So I'm going to divide both sides by 40. And I do get C is equal to 21. So he needs 21 customers. Does that make sense? Well, yeah, because if he rents his skis to the customers for $40 a day and he has 21 customers in total, then he's going to be making, let's see, so he's going to be making 21 times 40, so he's going to be making 840 bucks from the customers, but then he has to take away his rent cost, and his rent cost is $690. And when we do that, he's left with $150, which is exactly what we wanted. Let's do another word problem. Patty sells pies to customers at a price of $16 per pie. She starts the day with $90 in her cash register. How many pies? Okay, so we're going to let our variable be pies because I'm asking how many pies does Patty need to sell so that she has $538 in the cash register. So this is pretty similar to the previous problem. So she starts the day with 90 bucks in her cash register, and then adding onto it is how many pies she sells times 16. Right, because she's selling the pies for $16 a piece. So adding on to it 16 times the number of pies she sells, and she wants that to equal $538 at the end of the day. So let's go ahead and solve for P, it's the amount of pies. And to do that, I'm going to first subtract 90 from both sides. So I get 16P is equal to 448, and then I'll divide both sides by 16 to get P. So I get P is equal to 28. So she needs to sell 28 pies to end the day with $538 in the cash register.